Okay, I am going to be hopeful that my microphone positioning and my speaker positioning are going to be uh, advantageous, that we don't get feedback. For some reason, my MacBook isn't connecting to the Zoom, and I am going to be just a disembodied voice today.
Mhm.
So anyway, first of all, I'm going to thank Patrick for uh, starting this discussion on chapter 3 uh, last week. I also had quite a interesting time setting up the various packages and programs associated with the data engineering pipeline. Um, I think that just I got about 4 hours into it, and then I said, "Hey, I actually should start working on the actual chapter." Uh, so you know, people should not underestimate how the amount of setup this particular uh, uh, setup that he has developed entails. So just kind of in preparation for next week, because I think next week is a little bit more code focused. You might want to start early if you have not gotten everything running on your system already. I did not have quite as much problems with poetry, but I was also following the install from the README on the GitHub rather than the book, and I would recommend that. Um, so I'm going to share my screen, and we're going to go back to the diagram that Patrick was emphasizing last week. And let me see how to do this. Believe it or not, I'm not a Zoom guy. Okay. So this particular figure explains the architecture of what we're trying to do with developing a data set that we're going to be able to dump into the RAG format. Um, my focus today is going to be a little bit more code oriented, um, because I thought that there were some interesting aspects of what he was doing in terms of uh, data engineering and Python coding that I think we could all benefit from. Just so you guys know, I consider myself an intermediate level Python programmer, and I come at things from a data science viewpoint. So I'm like a pandas. I started off as a pandas and Jupyter guy, and I have kind of progressed to a VS Code, but still, obviously heavily in pandas. And we're talking about a very different structure here because we're dealing with the unstructured data. And if you think about what overall we're trying to do, we're creating a toy data set from 4 sources, and each of the sources are different types of unstructured data that we're dumping into a database. And because it's unstructured data, it's going to be organized by a NoSQL database. And they use the medium data set, um, the Substack data set, GitHub data set, and a LinkedIn data set. And you have to crawl the web under the specified sites and their dependencies when you are trying to get together this data. And then you need to put it into something that is going to be a repository. And from there, you can take the repository and you can start to translate it into functional uh, a functional data set that will feed into the LLM for the purposes of the RAG. And that's going to be, the vector database that he's using. Well, I don't know why that happened. So let's take off the annotation. So let's continue. And what I want to hold on, clear my annotations. So I want to skip forward to page 66, where we start to talk about the dispatcher and how do you instantiate the right crawler? How do you decide when your program is working and you're crawling the web? How do you decide how to get the data into the right format, into the right structure, so that you can ingest it and put it into the NoSQL data set? And so there are four different websites that we're going to be crawling, and each one has its own crawler essentially. So the way that these guys are doing it, it's actually, I think it's pretty sophisticated, and he is trying to create his data sets in two ways. The first way he is trying to make every data set be a class. So all your data sets are going to be structured under a class definition. And for those of you who are not Python programmers, a Python class is a structured and, more importantly, inheritable template. You're creating a object that has inheritance features, so you can take portions of that class and you can build other classes on top of it. And that's what we're doing here in the crawler dispatcher. Here, so this class, okay, is a class method, which means everything that it's doing focuses upon the class itself and not an instance of that class. What I mean by that is that the constructor is talking about all classes of crawler, everything that goes into the crawler dispatcher is going to be affected, as opposed to just this instance of something that is a crawler dispatcher. And then the way they do this is they build it with the CLS designation, and they set the dispatcher equal to CLS. So the purpose of this, and he talks about using a builder creational pattern. And this is something that I've seen before. It's kind of neat. It's a different way of thinking about data, and I would suggest you review this yourself. The link is in the book, but the idea being is that you can define an object, right? And if you define the basic representations of that object, that you have a house that has a roof and four walls and windows. Then you can add on different things to that house, but you're trying to reduce it to the lowest common denominator, the function of everything. Every constructor, it has that thing. So, as long as you define a house, then you can define a house with a garage by adding, the term, or method garage to that class as a super class. House with swimming pool, again, you could add a swimming pool, and you can add house with garage and swimming pool as well. So it gets a little bit more complicated, and this is I think it's a fairly complex design. I mean, if you're a database designer, you're probably used to this stuff. I do not truck in data sets. Most of what I do is, Python pandas, or, large data sets of images, which are fairly easy. but you know, it's an intelligent way to organize a data set so that you understand what's in it, and then you can change data sets as necessary. And that's what he's trying to do here, because he's going to make this base method, right, to build, okay? And then he's going to have a few others. And I think that this is the important line here. And this is, you know, you instantiate, you know, the crawler dispatcher by basically building it and then registering it, you know, do the register LinkedIn, register Medium, and you'd add the register GitHub and the register any. So they have the way that these different crawlers are going to identify what type of class you're going to have is going to be based upon the URL. Okay, so you're going to match the URL to see which type of class, like superclass, you're going to instantiate. So it could be a Medium class if you register Medium, a LinkedIn class if you register LinkedIn, a GitHub class if you register, you know, GitHub, and there's a generic one if it doesn't register any. They, you know, you use a regex statement here within the register function to decide if you're matching the past URL. And I think I should mention that with the inheritability of Python, when you're defining these classes, you're going to see a lot of, you know, self instances, and that's, you know, you're creating this method dot register with this data that you're going to pass to the register. So when you call register from this, like for example, let's say, you know, you're going through this chain, okay? So it's going to build, okay, I made a class of crawler dispatcher, and I'm going to try to register LinkedIn. The register LinkedIn is going to have the registration key of linkedin.com and be linked to the LinkedIn crawler. The GitHub is going to be github.com linked to the GitHub crawler. And then it's going to try to parse the register method is going to try to parse that domain, which is a string, according to this self-crawler's definition. By the way, a lot of times in Python, when you see an underscore at the front of the name definition, it's a sign that it's meant to be an internal definition that only exists within that sub procedure or that procedure or that class, and it's not supposed to go out. So they have a get crawler method. It's going to check if the regex expression matches, and it's going to return the correct crawler, or else it will log a warning. All right. Just make sure I hit everything I want to hit here. Okay, so let's go into the individual crawlers for a moment. By the way, does anybody have a problem with this chaining of the register? Is that like something that everybody kind of knows, or is that something that is not kind of, is that something you haven't seen before? Because I think it's important to understand it's not like an if then statement. It's more like, it goes down the line essentially, um, looking for each match when it instantiates. So you can go through each of them, but it's not it's not an if it stops, it stops executing. So you know, it's not it would never happen, but theoretically you could get some sort of a match with a really funky URL that wouldn't mean anything to more than one, I believe. All right. Okay, so now each of the crawlers is built around a base class that uses something called an abstract method. And this is not something that I have used before. And basically, you're importing this thing called an abstract method from the package ABC. And this is on page 69. When you import ABC, you define class of base crawler as a superclass of ABC. The model type of NoSQL based document, it's a little like a comment, but it's not. It's there to remind you that this is the type of model that we're creating. And then you use the decorator. Again, for Python non-Python people, a decorator is a @ in front of a word that's placed on a line before either a class or a procedure. And the decorator abstract method, so you have extract, and I believe that they give you just the extract class in the base model. You always call yourself because it's part of a class. Not always, but most of the time you will. The link, which is our URL, is going to be a string, and they're going to pass some additional keyword arguments. You will see from time to time in Python that you can pass args or kwargs, and args are just additional arguments that you haven't specified that you want to be passed along for heritability, and kwargs are keyword arguments, which are usually dictionaries, and they make a distinction in Python between the two as a design decision. And basically the default extraction is none. And I thought it was kind of interesting. There's actually like nothing here with that base crawler class. If you look at the left side of my screen, actually, can someone tell me, am I sharing the screen so you're seeing a black GitHub on the left?
Yes.
Okay, good. Thank you. So it's kind of interesting here. The class of base crawler, it's defined, and then it's just kind of it's just like a ... I'm not really quite sure. My linter kind of said, "Hey, there's supposed to be more here," so I'm not really quite sure if this is entirely kosher, but maybe because you're just creating super classes from it, it's fine. So they will extend this, okay, with the base Selenium crawler, which is which incorporates base crawler, and it's also incorporating ABC. And I think that you have to incorporate, once you start using the ABC abstract method, you have to kind of, make sure the other classes that you're wrapping around that abstract method also follow the abstract method. And these are just a number of arguments that are given that are supposed to be helpful for web crawling with Selenium. Haven't done a lot of web crawling myself, so I can't really tell you if this is, useful, not useful. I'm presuming he just got it from a repo and said, okay, that looks good. Um, so the let's see what else I'll do. The Selenium crawler will handle JavaScript rendered pages. There's auto installation Chrome. Most importantly, it has a headless browser configuration where you can browse without having to have a specified browser. It also has apparently scroll functionality, which they use. So if you have infinite feeds like a Twitter or a Facebook, you can still crawl those sites. Um, okay, so you're also disabling, stuff that's going to slow down your browser or rather your crawler, by like extensions and GPU utilization, just to make sure it's headless and functions. I thought this was kind of neat. There's a scroll page method uh, where you basically allow it to, read the page, wait a few seconds, and then try to scroll more down. Okay. So that is going to be the crawler dispatcher. Now let's talk about we could talk a little bit about the individual crawler classes. I think that this is just kind of, I don't know. It's, each one is different because you're scraping four different uh, websites. GitHub's easy base because you just basically git clone everything. And, they check to make sure that there is not, you didn't already clone the repo with the same web page. I guess you could clone the repo under a different web page. But I believe what it's doing here is it's taking the entire repo and it's maintaining the file structure of the repo, skipping the stuff that you don't really want to deal with. You don't really want to deal with the git ignores and things like that. But it's then stripping out spaces, okay, to store it, as a continuous chain of characters. And I think that that's, you know, relevant for LLM uh, data storage. Um, I honestly, I don't know how LLMs handle spaces. Uh, could look into that. Um, so, you can crawl each time it'll instantiate a new document once it crawls through the page and try to crawl to the next page, apparently, as it goes through the files that are in the repo, um, just iterating through that. And then it saves it to the MongoDB through an instance save. So you get a document that's based upon that GitHub repository file. Let me see if I can show you. So here's the code for the GitHub that we just kind of went through. And here is the custom article code. This is the custom article crawler class is based upon a synchronous HTML loader and a HTML to text transformer that are from the LangChain community. No experience. So presumably it works. What they're trying to do in each of these documents, so they're indexing them, and we'll see this later. They're indexing them according to a schema, and the schema is basically, you know, a unique identifier tied to either the URL or the author um, of that uh, document, and that's part of the MongoDB data structure. So they're going to grab the metadata, title, subtitle, content, language from the page, parse the URL, and save it into the MongoDB. Okay. Medium crawler, I think, is more of the same thing. The only thing that it uses Beautiful Soup for HTML parsing, and Beautiful Soup has been around. I've started to play with it a little bit in the past. It's pretty standard. Selenium, I think, is more powerful. I'm not sure why they decided to use Beautiful Soup instead of Selenium. Maybe someone who knows more about scraping can comment on that. But we basically, there are other tools like Scrapey. I've never used Crawl for AI, which looks interesting if it's a specialized LLM data crawler. So to summarize, you have these 4 crawlers that when they come across a web page of the appropriate variety will instantiate the class of that variety, scrape the data into that class, okay, and then take the data that is incorporated in that class and put it into a NoSQL data set as a document page. Is that clear to everybody? That's kind of like, I think that's the big important point of the last 20 pages. Okay. Can I have some thumbs up? Keep going, everybody. Good, everybody? Okay, awesome. So I'm going to shift gears a little bit, and I'm going to start to talk a little bit about the way they're setting up the NoSQL data warehouse. And again, he has an opinion that it's best practice to structure your data in classes instead of dictionaries, because you can then address each data, the collective data points in the data set as an object method, like a point something, as opposed to trying to, find a particular column or row in your data set. And I think that makes a lot of sense, particularly if you have a limited number of different data types that are in a textual basis. So it's really a different way of thinking. And I don't know about you guys, but I have, coming from, Python pandas, where I'm used to thinking, row and column, row and column, row and column, this is a very different way of thinking. And there's, substantial differences in this type of data set. Let me hang on. All right. So I cheat a lot. And that's like, I call GPT cheating. So I hope you are supportive of my cheating. And I think that, when we talk about the differences between SQL based data and no SQL based data, which is what we're going into, I mentally, I kind of wrap my head around, a pandas data frame, and a pandas data frame is going to be very similar to an SQL data set. Not the same, obviously, but it's similar. It's, a 2D table. SQL could be a multi-dimensional table, but when you have a NoSQL data set, it's going to be a collection. The records are going to be fixed in the SQL and the pandas data frame. It's not going to be fixed in the NoSQL, which is great because you don't know when the web page is going to end. There is nesting in the NoSQL data set. There is, flattening in the pandas and the SQL. You use keys in SQL. In Mongo, you use, object IDs, and you can index them with binary trees, both of them. The relationships are in SQL and Pandas are similar. You can join them, you can merge them, you can slice them. In Mongo, you embed them. So there are strong constraints in SQL. Pandas constraints are whatever you want, and NoSQL is weak constraints. The MongoDB is, I don't think it's particularly durable, as opposed to the SQL DB, which is very durable. And the NoSQL is very scalable. The SQL is horizontally scalable, and Pandas is just Pandas. So this gets us into, there are classes that they are, they're defining for the NoSQL case, and that's the article document class, the post document class, and the repository document class. They're all very similar. He then goes into an interesting discussion on object document mapping and object relational mapping. And again, not a database guy, but object relational mapping, is the 2D table of, or rather the table based methods of SQL. He mentions SQL Alchemy is a very popular one, also SQL model. And you have to do CRUD operations on, and CRUD operations are the basic data set operations that you're going to make in any database. Creating a record, reading the record, updating the record, or deleting the record. So he is going to code these 4 things individually, and he's going to code them on an example basis in SQL Alchemy first for us, okay? And then he's going to code them in an object-oriented paradigm using NoSQL for an object relation, so an object, an ODM solution. So he classifies a base class, user base here. Let's see where he wants. I think this is in snippets, if you want to see the code. Yeah. Okay, so this is, you can find this code in code snippets on the GitHub repo, and I'm showing that on the left side of the screen. He's basically, creating a base class, okay? Giving it an ID and a name. He's creating a way to insert new users, save it to a SQLite data set, and then you can query it. So the difference is that his ODM pattern is going to work with the NoSQL data sets and unstructured collections. And we're going to have to do the same CRUD operations as well. So he's going to implement the ODM class, and this is going to be in LLM engineering, domain, base, NoSQL. And you'll see that there's right next to it is a vector, and that's going to be for the vector database that we're going to eventually be going into. And that's why I believe that's why he calls this a twin, approach. So what he does is he is going to define a type variable T that's going to be bound to the NoSQL based document class using this generic module from Python. And so we're continuing to import the abstract methods so that we can have continuity. He's importing UUID to give everything a unique identifier, and he's importing generic from typing. This typing stuff is all working, I believe, with Pydantic, which is type checking to make sure you have your types straight during your code. And it's actually pretty. Pydantic it's a little bit of a pain, but if you've worked with tensors in the past in TensorFlow, and you're trying to figure out what shape tensor you're trying to use, and it's sometimes a little bit more than a guessing game, it's great. So trying to get the right types and the right type shapes, so that your data structures flow continuously through your nested procedures is a challenge. I think that the way this guy codes, and I'm not so experienced of a coder that I can make more of a comment on it. I think it's very Pythonic. If you are a crack Python programmer, a cracked object-oriented programmer, it makes a lot of sense if you're doing, production level code. For myself, my code is a lot, less nested, because I think the nesting, it gets sometimes difficult for me to understand and keep, seeing what's going on, because you're inheriting constantly. I like to, if I distill it down to that, I like to, make my procedures and classes a little bit more descriptive and encompassing. And then, once I've done a few of them, I will go and, distill it down in the future. But we're getting an end product here, I believe. So take a look at this on page 83. You're defining T as a type variable bound to the NoSQL based document. And you're going to instantiate a class of the NoSQL based document, okay, using the base model, okay, a generic type of T, bound to the NoSQL base and also of the abstract type. So they define in the NoSQL based document class an ID field as a UUID4 identifier, and they're going to define the methods double underscore EQ double underscore and double underscore hash double underscore to allow the instances to be compared and then hashed. There's a method to convert to Mongo and from Mongo. Okay. From Mongo is a class method. To Mongo is not. So then you can, so you can use the NoSQL base document class and instantiation of that with a period and a modifier to go between the two data sets. And then the save inserts it into a MongoDB collection. So you have, you're trying to, he's done a few other things like model dump here. And when I move my mouse, can you see me moving my mouse, guys? Or do I need to annotate that? Okay, cool. And he's done a few other things like a bulk dump and also a bulk insert. But basically you have in this class, you have the 4 different, CRUD operations. You can insert, you can create a document in the NoSQL database. You can update a document in the NoSQL database. You can delete the document, and you can read the document. And reading the document is, if you remember, the base model class that we're calling on in base model. Cool. Everybody's following me. Give me a thumbs up so I'm happy. Following or completely confused? All right. I'm going to keep going. We'll do questions later, and I'll try my best to answer them. Let me see if I want to hit anything else that's relevant here. Okay, cool. All right. So finally, we're going to implement the subclasses, okay, that inherit from the NoSQL base document class. And these are the concrete classes that define the data categories. And these are the classes like data category, document, repository document, and post document. And these are just, additional data structures for, saving one of the 4 types of crawl documents that we got through the 4 different methods in registry caller. And then there's a user document class as well. All right. So the last part of our discussion is the part about gathering raw data into the data warehouse. And I'm sorry to say I was not able to devote the time to get this to work, to test it. Just ran out of time. And what they're trying to do here is they use a ZenML configuration file, and use ZenML to form a pipeline to collect a different set of data for each of the different authors on their rags. And basically it loads, I think it loads their Substack, that loads their personal blog, it loads their LinkedIn, it loads their whatever. One of the LLMs I was using said that, hey, by the way, I don't think we can use LinkedIn anymore for this. So, you know, it might throw an error when we um, when we um, try it. So just kind of think about that. But basically, you run these NML pipelines, and they will ingest the data by crawling the data, and we'll give you an idea of how it's working and if it's successful, if it's not successful, as they crawl the different uh, data types and data URLs that were linked to these particular pipelines. And then there's another one that you can try it as well. And those run under Poetry Poe. So you have to have the Poetry Poe working for that to run. And then you'll see this if it's successful. So I am not going to go into the troubleshooting because I think, I really didn't have a chance to try it, and we all have our own issues with troubleshooting. So I think that the important points to understand, today were the construction of the internal database based upon classes and class inheritance, and how we start with, like basically we use a constructor type or builder type paradigm to start with a base class and expand it so that we can get the individual types of data that we need specific to each of the specific crawled sites. I think that was one thing. I think that another thing that was important is the difference between the ORM and the ODM paradigms for data warehousing in an LLM, and how we are warehousing our data in a NoSQL environment, which has its own CRUD operations hard coded, and the use of the abstract classes as well, and the use of the generic type class as well. So that, I think, are the things I wanted to hit today in this chapter to get us ready to actually go into some meat, which is next week on chapter 4. So this is all just, preparation, and getting us to there. And, I have let me see if I still have it up. I may have, no, I have it on my other dev box, my Unix dev box. By the way, for those of you just if you don't know, you can get some really cheap older computers that have some real horsepower and some pretty good muscle in terms of memory. If you're willing to, I have a Dell 5810 that I picked up for $200 that has 64 gigs of RAM, and didn't come with anything else. But I ended up swapping out the processor for I think a 16 core Xeon top of the line, back in 2015, that cost about, I don't know, $5,000 or a little less, probably 2,000. And I ended up picking up for $100. So you can get some real horsepower if you're looking for, horsepower and memory. If you just go to older systems, obviously we can't get a terabyte of memory, to hold an entire, full model without a newer system, but just something to be aware of. Um, and all right, I think
What Xeon
that's
processor did you say you got?
it's like a good question. Hang on. It's like the one I have is it's like a 16 core 2895 V4, something like that. It's like the last it's like the last model that fits the old socket, you know. It's just you can get it's really powerful stuff, but it's obviously it's old, but it's still these are good, server chips that are just they're good, they're powerful.
Does it run Windows 11 on its motherboard?
I don't run Windows 11 on that. Um, I have my old dev box, unfortunately. Um, I have I don't have Windows compatibility on it because it's an LGA you know V3. So I kind of just missed out. It's a workstation motherboard, so I don't have the DRM chip. So Windows 11 isn't compatible, so I'm going to have to build a new box for my Windows box soon, which is a shame because I love this. I have this one. I have 64 gigs of DDR4 and um, uh, 16 terabytes storage with a 6850 processor,
Hmm.
6850K. Um, but the old style processors are fairly cheap, and I think in terms of like the if you're doing Linux stuff, you know, more cores is better as opposed to like
Hmm.
for gaming where you want something faster.
Yeah, but like with the new Windows 11 and the Azure, Microsoft, like they're building up like their own version of that Windows Store. I forget the official name. So they are building everything for Windows 11 right now, and plus with the DRM chips that you mentioned. So that for the core audience that like want to work on a Unix or a Linux machine, that is necessary. Like you can have a older system that you can run Linux on to get your inference and training pipelines sometimes run on that stuff, but like for the newer systems that with specifically if you look at the last this uh, Microsoft build that happened a, a month or a couple of months back, in which they like detailed about their Foundry and your Windows 11 local kind of uh, LLMs that local LLMs that you can run off directly out of their stuff. So like, and plus how they are integrating it with agents and other stuff. So like for the AI development and inference as well as use, I think so Microsoft is doing much more than Mac OS or Linux like combined, and like they are like spearheading their development here, and so it will be interesting to like look at and uh, like in the future. Uh, uh, I'm not advocating for it, but like I've found some of the features that they are coming up with really interesting. And since they're using it in multiple ways, like with the Office and their Outlook and their stuff, so like for a holistic stuff, as well as when you're trying to give commands like we do nowadays, like just with the your microphone and stuff, so it transcribes quickly too. So and uh you can run an agent overnight that solves complex problems. So like in those cases that this will be helpful. So yeah, that's one of my.
Yeah, I spent a lot of time in 2017, trying to, my friend and I, this is when we were like spending a lot of time on CNNs, and my friend was using Windows, and I could never get it to work, properly back in 2017. But this is like with, early implementations of Docker before Microsoft bought them. And, I kind of came to the conclusion that, if you want to be doing anything serious in AI and, AI coding, you had to, you know, you had to make the jump and you had to go to Linux. Uh, and ended up dual booting that PC, so I could swap between Linux and Windows 10. And I honestly, I really never was able to get AI applications running well in Windows, but I never really had, as much of a problem, getting PyTorch or, some of the other, TensorFlow to run, Keras to run in Ubuntu. And, I think that, my viewpoint is Microsoft is like, for, Windows is for like, web browsing applications, you know, normal stuff, but if you're going into development, I think, you have to be developing on, Linux. And it really, I think it makes a difference because there's so much more you can do in Linux so easily. And, conversely, virtualization and things like that. And conversely, Microsoft kind of fights you a certain way. You have to do within Docker, you have to, you know, do some other things, or something hinky, you know, conflicts. So, if you're trying to get it working Linux, later on, I think you can, if you need to produce it, you can produce it through Microsoft and maybe even transport it to the Azure cloud. But, I have not had much experience with that. So, you know, that's just what I have tried. All right. Any, you know, significant questions? Uh, don't feel obliged. This is just something I think we had to get through so that we can get through to the meet next week.
Hello, good
Yeah,
afternoon.
more than well.
Right.
Sorry, someone
Hi.
someone else has type a question.
Yes,
Oh,
please.
I was just gonna say.
Yeah.
Go.
Okay. Okay. Oh,
Sorry,
sorry,
I
Carlos,
was.
you can go ahead. Go ahead when you're done.
Okay, thank you. I was just gonna say thank you, Stephen, for the presentation. It was a great presentation. I was going, more than a question. I was gonna make like a comment. I also have tiny issue at the beginning when I was reading the chapter, understanding why we were using so many different technologies for scrapping. I would have liked to have in the chapter some tiny explanation of the different technologies that you can use and why in some cases we use some of the tools and why in some cases we use different ones, like why we use Selenium but then we use Beautiful Soup if we already have Selenium, probably because it's more efficient, because when you don't need JavaScript you can just use something simpler where there is no browser involved, but there is no explanation, so we have to kind of think about it. But aside than that, it's everything clear from my side.
Okay, good. Yeah, I think, again, when I write code, and I'm not a professional programmer, I don't write code that is as nested in terms of classes as, the authors do here. And I think that it impinges upon the readability and understandability when you're inheriting. It's hard to, keep things, in mind. So if you're struggling, trying to read and understand the code from that respect, just kind of, I don't know, just kind of go with it. I wish I had an easier way to to tell you how to, to go through the levels and, to understand what they're doing. But I think that if you were to code your own code, you would code it a lot less Pythonically and, more to, the point to try to get something done and going. And you would find that a little bit easier to understand. So if you're frustrated, don't be entirely frustrated. It's just the way that's written. And that's it. I got nothing else for you.
Emmanuel, did you have a question also?
Yes, Carlos. Thank you very much. Thank you, Stephen, for the presentation. Yes, I think I joined in late, so I don't know if what I'm going to ask it was discussed or I missed it. When I started reading the book, there was this question that has been bugging my mind, and I've not really read the chapter 3 well, so I don't know. I'm not that regular on GitHub, social media, and other stuff. So I was wondering, does the book provide some data that we can use for the project, or if it doesn't provide, which other way can we get data for the project?
I mean, Emmanuel, my impression is that, all the code is on GitHub, and the Git repository, you would have to clone to your local machine and, install the packages that are there to even have a chance of most of this running. So, it's a kind, it's a complex series of programs that he's using, and not only just programs that he's using, it extensions on the programs that you have to download to your local machine. So I would suggest GitHub is not a social media site. GitHub is a code repository. I would suggest making a GitHub account and getting familiar with it, and getting familiar with Git, because Git's kind of like basic production code, how almost everybody does it in production code environments, I believe. I think it's a good thing to learn. I think it's a good thing to know how to utilize. And I think you'll spin your wheels and get very frustrated unless you're interested in it from an abstract level. If you're trying to actually run the programs yourself without the Git, it's going to be really difficult. You don't want to do that to yourself. So save yourself a little bit of pain.
Yeah, thank you. I think maybe you got me wrong. What I'm trying to say is, does the repository come with the data that I will need to train the model? Because from the beginning, I think from chapter 1, chapter 2, it says we are going to use our X user account, then a Medium, then GitHub repository, GitHub account for the data. So we are going to crawl these pages for the data to train the model. So, and as I said, I'm not regular there, and I don't have much information on these sites or these platforms. So I'm asking, is there a way we can get the data, or we just have to use our own?
At the end of the chapter 3, there is a mention that says that if you had problems, I mean, the suggested way is to follow the chapter as Stephen did. So that if you do that, that downloads all the articles from the different sources. But if you have any problems with that, or you, let's say, don't have good internet connection or something like that, there is a script that apparently loads a backup of the data from a JSON file. Is the last command in the chapter. So that's an alternative if you just want to get the data running. Anyway, someone was suggesting in the comments in the chat of the group to actually use Docker. I think there is a very good suggestion, because for this chapter we needed MongoDB. But for next chapter, we're going to be needing Quadrant, the vector database. And if you have Docker, in my case, it was as simple as Docker Compose app. and I have the services running. I didn't have to do anything else, and I can only the Poetry install for installing the dependencies. So in my case, it was really easy, and I have all the services. In my case, everything was working out of the box. So.
Well, as I recall, it even installed MongoDB. But yeah, I mean, also if you have questions as you step through things, then use the Discord website, because that's the more social place. You can ask specific questions, and I'm sure that various users in the group are going to see it and be willing to help, because I know it's going to be a challenge for anybody, especially if you haven't worked with all these different parts and layers and whatnot. There's so many things to be concerned about, and you may overlook. So if you do the first 10 steps well, and you hit the 11th step, then that gives you context. Okay, this is where I'm at, guys. What do I need to do? And I'm sure someone will have an idea.
Okay, thank you.
All right, I am done. Thank you very much for all your attention today. And Carlos, who's going to do next week?
Yeah, this is a moment for volunteering. If anyone wants to lead the chapter 4 on RAG. I think that we are going to have to do that in 2 parts, maybe, because it's about 75 pages or something like that. So probably it would be a good idea to also split it in 2.
Ash didn't show up today. We should volunteer him.
Anyone? Ed, volunteer?
Yeah, Ed.
Okay,
Nice, Ed.
thank you very much. Okay, so just for the record, in 15 minutes, we're going to have the first session for the hands-on machine learning book. So just if you want to like make a tiny break, and then we will see each other again.
Is this going to be the same Zoom oral? It's a different one, right?
I believe it's a different one.
Right. I just mentioned that because some people may have missed it.
Yeah. I'll repost it on Discord, write an announcement. But yeah. Cool. Thank you, Ed, for leading next week. All right. I think that's it, right? See you guys. Thanks,
guys next
Stephen.
week. Thank you very
That was a
much.
great presentation.
All right. Later. Thank you.
Bye, folks. Take care.